Lesson 5.2, Proving Trig Identities. Remember, an identity is simply an equation that holds true for all x values in the domain. Okay, so we're going to be using identities from Lesson 5.1. And the basic strategy for these proofs is we're going to start with the more difficult side of the equation and simplify until we get to the other side. In example 1, we're going to start with a proof that only involves algebra. We're not even going to have to use any trig. So we want to start with the more difficult side, which in this first example is the left side of the equation. So we have x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1. Okay, so what we want to do is simplify this left side of the equation until we get to the right side. So all this should simplify down to 2. If you look at the numerator, you should recognize those are a difference of squares. So they factor into x plus 1 times x minus 1 over x minus 1 minus x plus 1 times x minus 1 over x plus 1. So looking at both these fractions, we can see things will simplify. We have x minus 1 divided by x minus 1, which is just the value of 1, and x plus 1 divided by x plus 1, which will simplify down to 1. So that all simplifies down to x plus 1 minus the quantity x minus 1. If we distribute this negative through, we have x plus 1 minus x plus 1. Okay, we can see we have a positive x and a negative x, which cancel each other out. So 1 plus 1, we're left with 2. So we started with the more difficult side, used algebra to simplify and rewrite to get it to the right side of the equation, which was 2. In example 2, we want to prove that tangent x plus cotangent x equals secant x times cosecant x. So first thing we need to do is determine which side is more difficult, because that's the side we want to start with. On the left side of the equation we have 2 terms, and on the right side we only have 1 term. So we're going to start with the left side of the equation. It's slightly more difficult because of those 2 terms. So we have tangent x plus cotangent x. Talked about this strategy in lesson 1. It helps to rewrite everything in terms of sine and cosine. So we can rewrite tangent x as sine x over cosine x, and we can rewrite cotangent as cosine x over sine x. Okay. Since we have 2 fractions, if we looked at the right side of the equation, we only have 1 term, so we need to combine these 2 terms, which means we need to get a common denominator. So this is equal to sine x over cosine x, and I'm going to multiply by sine x over sine x. Our common denominator is going to be cosine x sine x plus cosine x over sine x, and we need to multiply this by cosine x over cosine x. Now if we want to simplify the numerators, sine x times sine x is sine squared x. Cosine x times cosine x is cosine squared x. And we can write this as 1 fraction. Cosine x sine x. Now if you look at the numerator, you should start to recognize that it is our Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. So our numerator simplifies to just 1 over cosine x times sine x. And if we look at what we're trying to prove on the right side of the equation, we have two trig functions. So we're going to rewrite this as 1 over cosine x times 1 over sine x. We're just going to break this up into two fractions that are being multiplied. We know 1 over cosine reciprocal function, that relates to secant x, times 1 over sine is cosecant x. So we started with a slightly more difficult side of the equation, used some of our trig properties, and simplified down to the right side of the equation, which was secant x, cosecant x. Example 3, we want to prove cosine t divided by 1 minus sine t is equal to 1 plus sine t over cosine t. So first step, just like the last problem, we need to determine which side is more difficult. The sides are fairly equal in how difficult they are to simplify, but we're going to start with the left side because there's two terms in the denominator. So that is slightly more difficult to work with. So we're going to start with cosine of t over 1 minus sine t. And I'm going to multiply this fraction by 1 plus sine of t over 1 plus sine of t. The reason I'm going to do that is because this is going to create the Pythagorean identity in the denominator that will simplify. Okay, the only way you're going to get good with this is practice, practice, practice. Be creative and try things. You probably would not have thought to multiply by this fraction in the beginning when you were starting this. Okay? It's going to take a lot of time and practice before you get good at simplifying these proofs. This is going to simplify into cosine of t over, or times 1 plus sine of t divided by this. If we would FOIL this out, our middle terms are going to cancel out, so we're left with 1 minus sine squared t, which is where our Pythagorean identity is going to come into play. If we take our main Pythagorean identity, sine squared t plus cosine squared t equals 1, if we would rearrange that a little bit, 1 minus sine squared t is equal to cosine squared t. So we have cosine t times 1 plus sine of t, all divided by cosine squared t. So now if we look, we got a common factor in the numerator and denominator, cosine t, and we have cosine t in the denominator. So we're left with 1 plus sine of t over cosine t. So we started with the slightly more difficult side of this equation, used our Pythagorean identity to simplify the denominator, and got down into 1 plus sine t over cosine t. Example 4, we want to prove cotangent squared u divided by 1 plus cosecant u is equal to cotangent u times the quantity secant u minus tangent u. Okay, this is a fairly complicated problem, and first thing, we're going to start with the left side of the equation because we have a fraction with two terms in the denominator, slightly more difficult. So we have cotangent squared u divided by 1 plus cosecant u. We can use one of our other Pythagorean identities to rewrite the numerator. Cotangent squared u is equal to cosecant squared u minus 1 over 1 plus cosecant u. Okay. That top part is a difference of two squares, so that factors into cosecant u plus 1 times cosecant u minus 1, all divided by 1 plus cosecant u. So we have cosecant u plus 1, 1 plus cosecant u. Those cancel each other out. So we're left with cosecant u minus 1. Okay. At this point, it's hard to be creative and think of a way to continue on and get to the right side of the equation. Okay? So, one strategy we can do when we get these difficult problems is start with the left side of the equation, simplify it to a point where we can't continue anymore. Now we're going to start with the right side of the equation and simplify that to see if we can simplify it to the same point. So if we start with the left side of the equation and the right side of the equation, and we simplify both of those down to the same point, well, it's kind of like our transitive property from geometry. That's proving that those two sides, the left hand and the right hand, must be equal to each other. So now if we start with that right side of the equation, cotangent u times secant u minus tangent u, we want to simplify this down and see if we can get it to simplify to cosecant u minus 1. So first thing I'm going to do is rewrite everything in terms of sine and cosine. So this is cosine u over sine u times the quantity. Secant u is the same as 1 over cosine minus tangent is sine of u over cosine of u. Rewrite everything in terms of sine and cosine. Now, if we multiply this first fraction by the first fraction distributed through, we're going to have the cosine in the numerator and denominator will cancel out, so we'll be left with 1 over sine of u. And then if we distribute this first fraction by the second fraction, we'll have cosine u times sine u divided by sine u times cosine u. So we have something divided by itself. That actually simplifies down to 1. So we have 1 over sine u minus 1. Okay, 1 over sine u is cosecant u minus 1. Okay, and that's where we wanted to simplify it to. So we have the left-handed side of our equation that we simplified down to cosecant u minus 1. Then we started with the right-hand side of our equation, which simplified down to cosecant u minus 1. So by that transitive property, we've shown our proof. So now we can combine this all into one long process. So now we can take both parts and combine it into one. So we started with cotangent squared u divided by 1 plus cosecant u equals cosecant squared u minus 1 divided by 1 plus cosecant u. We broke that down because that was the difference of two squares. Part of the numerator and denominator canceled out, and we got cosecant u minus 1. Okay, this was where we went to the second part, or the right part of our equation, and now we're going to work backwards from that part. So that could simplify down to 1 over sine u minus 1. That's simplified down into cosine u divided by sine of u times the quantity 1 over cosine u minus sine u over cosine u, which simplified down to cotangent u times the quantity secant u minus tangent u. Okay, so this was a really complicated process. We had to start from both sides of the equation, simplify to get to the same point, but it is possible. You can go ahead and get started on the homework. This is going to be difficult. I understand that you need to have patience, and you need to try many different things. You are not going to get this right or simplify or solve a proof the first time. You're going to have to try something, figure out that's not the way you should go, and try a different path to try to get the proof complete. Okay? If you try one thing and then come to me, try to help, it's not going to work. You need to try multiple things and show me what you've tried before I even think about helping you. Okay? You're going to have plenty of time to work, but which you need to persevere and be patient with these.